Hello, Bricksters. Hello, welcome back. Thank you for joining us. We're so glad you're here. If you're just joining us now, I hope you get a chance to go back and take a look at our session that we just hosted prior to this with Elise, and take a look for Knowledge Assistant, which is now in beta, and also that multi-agent supervisor coming to beta very soon. Let's take a minute and review what we've got coming up for later this afternoon. So, following this introduction, we're going to hear from Bilal and Michael, and they're going to talk to us about Lakeflow. And then shortly after that, we'll hear about building AI-powered apps. We heard quite a bit about apps in our keynote this morning. And then Lexi's going to show us how to build a roadmap for impact on the business in just 30 minutes. And then we'll finish things up with elevating SQL productivity and take a look at some things within Notebook. So I'm super excited again for all of you to be joining us. This next talk is probably one of the talks I've been looking forward to most, because Lakeflow Connect, Lakeflow is just, it's making everything easier. Again, we talk about the importance of democratizing data and data intelligence for everybody. And one of the hardest things is just getting all of the data in one place. And so Michael and Bilal are going to tell us how you can use now these low-code, no-code approaches to ingest all of your data. They're also going to share the roadmap with us. Super excited to introduce Bilal and Michael. So Bilal is one of our senior directors of product management, and Michael is the original creator of Sparks. So excited to have him in the room with us. So with that, I'll turn it over to the team. Gentlemen, take it away.
Awesome. All right. Good afternoon. Everybody had lunch? Awesome. Thank you. Was it good? Okay. Well, thank you so much. This is a post-lunch meeting, which means, you're probably a little tired. You want to take a nap. We hope it's an exciting conversation. So I'm Bilal.
And I'm Michael.
Awesome. And we're excited to talk to you about Lakeflow. There's going to be a lot of stuff tomorrow. I do want to apologize and be very honest. The abstract says we're going to do 2 big unveils. Actually, this session was supposed to be after tomorrow's keynote. You would have seen the unveils and would have gotten into depth. But you can see one of the big announcements today at Michael's talk,
Yes.
which is a little bit later.
Yeah, it's declarative pipelines in Apache Spark, if you want to see that today. And then we'll be doing a deep dive on Lakeflow declarative pipelines tomorrow.
Yeah, awesome. And then there's one more, which is actually massive. You have to wait till tomorrow for that. So I don't want you to walk away disappointed saying, hey, this was false advertising or something. It's just we had a little bit of crossed wires over here. OK, awesome. So welcome, everybody. We have Michael for half an hour. So I'm going to do something a little non-traditional. You're going to see a lot of ingest, transform, orchestrate tomorrow. Today, I'm just going to tell you a little bit about what is Lakeflow, just in case you don't know, and just to bring you up to speed. And then Michael's going to talk about the transform piece first. So a little bit of creative sequencing over here. Forward-looking statement. You've probably seen this a million times. This is an informational presentation. It's not a promise. Perfect. Please complete your surveys. We do listen to feedback. Excellent. So what does this talk about? We are going to be talking to you about how we are unifying data engineering with Lakeflow. But it's actually not just why. We're actually going to get into the roadmap. And there's plenty of time for Q&A. So please hold on to your questions. There'll be time. Raise your hands. Ask those questions. So one thing I wanted to do was very quickly talk about where does Lakeflow fit into the data intelligence platform? And this is where it fits in. You have Mosaic AI for artificial intelligence. You have Databricks SQL for data warehousing. You have AI BI for business intelligence. And Lakeflow covers data engineering. It is how you ingest, transform, and orchestrate data into Databricks. And of course, this is all built on top of Unity catalogs. You get a single layer of governance, and everything is unified. I love this quote from one of our customers, JetBlue. I think it's worth reading it out loud because I've actually found this to be true in 100% of places. And by the way, this is the big why behind Lakeflow. Carol Clement says, you can have all the AI in the world, but if it's on a shaky data foundation, then it's not going to bring any value. The one way I've heard a customer say this is, everything starts with good data. And that's actually the why behind Lakeflow. So if you take one thing away from this whole presentation and conversation is Lakeflow is how you get great data into your business. And if you don't do that, if you don't use Lakeflow, what I see often happening in customers and out there in the wild is, well, you have to stitch together a lot of these tools. You get this really fragmented stack. This leads to governance problems. You get complexity and inefficient data pipelines. So don't do that. You are going to see a lot of announcements around Lakeflow tomorrow. I do believe it's the future of data engineering, and you should use it. And one of the big things about Lakeflow is it's now generally available, and we're going to announce that tomorrow. We're seeing a lot of success with Lakeflow. We have thousands of customers already using different parts of Lakeflow. So it's generally available, being used actually heavily, and lots of gains in productivity. So while we have Michael, I want to make sure that we talk about one super important part of Lakeflow. So Michael, take it away, please.
Yeah. Thank you, Dalal. And so, one big part of Lakeflow is the ability to transform data. All data starts off messy, and you need to get it ready. You need to clean it, filter, augment, join, so that it's ready for consumption by the business. Traditionally, we did this with Lakeflow DLT, and tomorrow we're going to be announcing that we're renaming this Lakeflow Declarative Pipelines. You get a sneak preview into this by coming to this session. But before we get into that, I want to kind of go into a little bit of a history lesson. Often declarative programming seems so simple you don't realize the power of what's going on under the covers. So I want to do a case study here where we look at an incredibly common data transformation we need to do called change data capture, and look at what actually makes it difficult and how Lakeflow can simplify that. So the problem is super simple. I have this change feed coming from some other system. It could be Postgres, it could be MySQL, it could be some other operational system, and I'm getting this list of changes and the time that they happened and the new data for that record. There's a primary key, and what I want to do is take the latest record for every key and then store it into a table. Sounds really simple, but there's a lot of hidden complexities due to out-of-order data and other race conditions that you can run into. So if you go on to Google and you type in, change data capture with Spark, you're going to get some source code like this. And so it's actually kind of already looking a little bit complicated. We're going to read the stream of changes, and then we're going to have this function that takes each change and merges it into the Delta table. Looks pretty good, but actually there's a bunch of subtle problems with this implementation. The first problem is it's not handling the case where there are multiple updates to the same key within a single microbatch. Merge is just going to explode and say, I don't know which of these rows to pick with the current implementation, and so you need to fix that. We need to tell merge which one is the most important by looking at that timestamp. So it's pretty simple. We'll just add an aggregation to each microbatch. We'll group by the primary key. We'll take the row with the greatest timestamp for each key. We'll explode it back out so it looks the same. You can see what that transformation is doing here. And so we'll add that into our code. And now it's a little bit more complicated. We're up to 18 lines of code. Unfortunately, it's still not correct. There's another problem when out-of-order updates come across different microbatches. Now we're not going to see them in that single aggregation anymore, and so we're actually going to end up picking the wrong one. We're going to end up with stale data in our table, and we'll never correct it. And so in order to fix that, we have to do something a little bit more complicated. We actually have to, every time we do a merge, we need to store the timestamp for that row in the table so that when we get a new record, we can check to see if that timestamp is greater and only update the row in the table if it is greater. So we'll go out and we'll kind of expand the merge. We have to do this for every single column in the table. Ends up being a little bit more complicated. We're now at over 20 lines of code. And unfortunately, it's still not correct. There's still some subtle problems with it. We want to also handle deletes. And so often source systems will give you this is deleted flag. So we'll have to go and change the code to do that. OK, well, that seems pretty simple. But unfortunately, we actually introduced another race condition when we did that. We now have, so we're even at 23 lines of code. There's still a problem with it. The problem is what happens when an update arrives late after a delete. So a record should be deleted, but now an earlier update comes in. That record is going to be reborn as a zombie, and so now this row that should be dead is going to be permanently trapped in our table, confusing all of our downstream consumers. And so the solution to this is getting a little bit more complicated. Instead of deleting records, we're actually going to soft delete them by recording the timestamp when the record was deleted. We'll call these tombstones. We don't want our records to see these tombstones, so we'll create a view on top that filters them out, and then we'll redirect all of our consumers to look at that view. And then, of course, we don't want these tombstones to pile up and continue taking up storage forever. And so we'll have to build a cleanup process that removes the tombstones over time. So looking at the implementation, we're going to have to add a few more lines of code. We're going to have to create this view and redirect all of our readers to it. We're going to have to create a separate job that now we have to monitor and make sure it's always working to do this cleanup process. We're at 24 lines of code, one view, one cleanup job. And that's pretty complicated. You shouldn't have to become an expert in distributed systems and race conditions in order to do basic data engineering. And that's why we created AutoCDC. AutoCDC, with 5 lines of code, does everything that I just talked about. And the magic trick here is something that we call declarative programming. Instead of procedural or imperative programming, where you give the system the exact steps of how things are going to happen, with declarative programming, you say what you want to have happen, and the system automatically figures out how to make that true. And this is the core idea underneath Lakeflow pipelines. So looking at this, it's pretty simple. We're writing into this table called CDC data from this stream called source data. We tell it that the primary key is ID. We tell it which column is our timestamp. We tell it when to do deletes. And that takes care of everything automatically. And if there's some other problems that you might need to add on to this, like, for example, it's very common for source systems to save space by only sending you the columns that change. So in this case, we were only getting the name in the first record, and we're only getting the city in the second record. And what the system should do is it should combine them to create a complete record, as you can see here. And adding that, if you were doing this procedurally, is actually quite complicated. You would actually, instead of keeping a single version, you would have to start storing a vector clock, one for each column inside of the table. But with declarative programming, it's as simple as adding one more clause to AutoCDC. We just say ignore null updates, still 5 lines of code. And there's some more features that I actually don't even have time to talk about. But for those of you who need to keep history, if you're in a regulated industry and it's very important for you to be able to go back in time and see exactly what the data looked like at any period in time, that's often called SCD2, which is where you keep this history. I would love to explain how that works, but we don't have time in this talk. And really, kind of the key idea here is AutoCDC is over 2,000 lines of code that you're kind of getting for free when you write these 5 lines. And I think even more important than the implementation is the 10,000 lines of tests that are checking to make sure that it's always doing the right thing no matter what order the data arrives in.
Michael, can I ask you one question?
Yeah, please.
How many hand-rolled implementations of automatic SCD type 1 and 2 have you seen? Roughly?
I have seen, hundreds, easily.
Okay. And how many correct ones have you seen?
I think AutoCDC is the only correct one I have ever seen.
Great.
It's actually like one of my favorite things to go and kind of snipe them now when I see them and point out the race conditions.
Awesome. Great. And is it fair to say that Lakeflow Pipelines is overall a declarative framework?
Yes, exactly. So this is one example of declarative programming inside of Lakeflow Pipelines, but really we make lots of things from ingestion to change data capture to doing transformations. All of those become declarative when you're programming in Lakeflow Pipelines. Awesome. And with that, I'm going to hand it back to Bilal.
Awesome. Thank you, Michael. OK, great. All right, so we're going to I'm going to go talk about, so that was Lakeflow pipelines, declarative pipelines, and you're going to hear a lot more about it, and I'm going to take questions. But I went out of order a little bit. Let me talk a little bit about Lakeflow Connect. So who here is ingesting data from more than one source? Great. So like every hand went up. And let me ask, I promise, one more question. Who here is ingesting data from databases? OK, awesome. Great. Who here likes ingesting data from databases? Like nobody, right? So look, the Lakeflow Connect is how you ingest all your data into one place. And it's actually the first step of Lakeflow. That's why I was saying we went out of order, because Lakeflow declarative pipelines is how you transform it. But the very first step, when I said everything starts with good data, well, you actually have to get the data into Databricks first. And that's actually the job of Lakeflow Connect. Now, we're going to talk about roadmap and kind of what's coming in a little bit. But I did want to share this one insight that came across from hundreds of customer interviews, which is that ingestion is absolutely undifferentiated heavy lifting, by which I mean nobody likes doing it. It's a necessity. You have to ingest data. You have to do it securely, safely, at the right cost. But I love writing connectors to ingest data, said nobody ever. It's like literally a thankless job, very important for those people who do it. Thank you, but data engineers don't like doing this. That's because it's not simple. It's actually very complicated. It's a very difficult job. You have to write the code. which can seem easy. You could vibe code a connector in 10 minutes, but then you have to deploy it, which means you have to run it. You have to keep up with API changes. And this is actually very, very difficult. I think Salesforce, the Sales Cloud is on API version 40. So some poor person has sat through 40 API changes, kept up with them, and possibly many more minor version changes. You have to deal with operations. So you have to deal with things like backfills, which means, hey, what if I'm missing a day's worth of data? What if the API went down? What if I have to go refresh a particular table, but not all the other tables? That's your job now if you're writing the code yourself. You have to monitor this. So you have to monitor both your connector, but you also have to monitor the API. Whether it's a database, you have to heartbeat that. You have to make sure that it's not going down. And it's costly. All of this adds up to time and money. And the tyranny of this is that this is time and money that's being taken away from the actual work we have to do as data engineers, which is to help deliver value to the business. So Connect makes ingestion point and click. And when I say point and click, I mean there's literally a super awesome UI. I'll show it to you in a minute. But of course, we're data engineers. We like to automate things. And it comes with a really powerful API. So you can actually set up your sources and destinations, and you can script it. So you go from having to write code. There's no code to write. You use an API call or the UI to set up a connector. You don't have to deploy anything. We run everything for you. We run the serverless compute or the classic compute. We take care of ingestion for you. You don't have to keep up with API changes. So you don't have to care. You don't have to worry about Salesforce, NetSuite, Workday, various flavors of SQL Server and Postgres. We take care of that for you. You don't deal with backfills. And the cool thing here is that under the covers, Lakeflow Connect just creates DLTs, or now they're known as declarative pipelines. You get the full semantics. You can do full refreshes. You can do partial refreshes. You have retries. These are triggered entities. So they're actually managed by Jobs, which is the orchestrator. So you're not reinventing a new thing. Monitoring is already included. Again, this is because these are pipelines. They're just standard first-class pipelines. So you don't have to build anything secondary. So you get cost observability. You get data movement observability. It's just included. And it's not costly for two reasons. First, you can spend your time and money elsewhere. You can go actually do data engineering. Secondly, it's built on declarative pipelines, which means that it's incremental and efficient from the get-go. This is important, and I'll tell you about kind of two cases. One is most SaaS sources support some kind of incremental ingest. So we do our very best to do incremental ingestion. And there are like lots of cases where we have to do tricks on your behalf to keep doing incremental ingestion, to avoid refreshes. Salesforce formula fields, for example. And for databases, we use the binary log of the database. So if you have SQL Server, there are a couple of ways to do change data capture. We do that for you. So we're always reading the changes whenever possible. So I want to spend a little bit of time on this. This is the current set of connectors that are available. We are expanding in, this is so the way to think about this is there are three types of sources we want to make available. First is applications. So we have Salesforce and Workday. And we have previews of ServiceNow, Google Analytics 4, and NetSuite is in private preview. And Dynamics 365 is in development right now. These are the applications. For file sources, we have the popular cloud storage sources. We also have SharePoint, which is pretty awesome. So if you have a RAG or AI use case, it's very common that your business has a repository. It could be SharePoint. It could be Google Drive. But that's where you store all your unstructured data. And what we let you do is we let you bring that into Unity Catalog, into a volume. And soon we will be able to bring in the ACLs, the access list, into Delta tables as well. So you can basically mirror SharePoint into Databricks. And so you get to get all the data in, and then you can use it for AI use cases. This is super powerful. And then you can use it with the AI capabilities. We also have a secure FTP connector, very, very popular in private preview. And that's great for many legacy systems. For databases, this list is actually slightly old. You'll see, I'll give you a little bit of a sneak peek for tomorrow. We have SQL Server in public preview. Postgres is coming, so we're actually announcing the private preview of Postgres tomorrow. MySQL is under active development. Oracle is later this year. And tomorrow, you're going to see a lot more logos for databases on the slides. And what we're doing, the cool thing we're doing here is if you have a database connected into Unity Catalog via Lakehouse Federation, you'll be able to use that from within Lakeflow Connect to do incremental ETL. So the way that'll work is it's going to be cursor-based ingest. So you have to tell us, hey, here's the updated add column, for example, or use this as the, you use this to capture the changes. For smaller databases under, in the range of several hundred million, you'll be able to load data from Snowflake, Teradata, Oracle. It's not binary log, but it actually unlocks a whole set of possibilities. And if you already have it mounted in Unity Catalog, it just works, which is pretty awesome. So that's going to be announced tomorrow. And lots more coming. Cool. Let's talk real quick about LakeFlow Jobs. So who here is using LakeFlow Jobs today? You may know as workflows, for example. OK, awesome. Great. We're settling on the name jobs for this capability, because today we use workflows to create jobs. It's a little confusing. And jobs is an orchestrator. This is actually how you run workloads in production. And I want to talk a little bit about the evolution and to give you a sense of where we're going with it, since this is a roadmap conversation. So circa 2016 or so, jobs was pretty awesome, because prior to this, how would you run Spark in production? Let's say you have a production Spark workload where you have to have some cron script sitting on a virtual machine, and you make an API call to a Livy API or some EMR API or Databricks API that spins up a cluster. Then you have to wait till the cluster's up and running. Then you submit the jobs to it and all that, right? How do you monitor this? How do you deploy this? How do you do logging? So that was the first purpose of jobs in Databricks, was to be a scheduler for Spark clusters, for Databricks runtime clusters. And that actually made life a lot easier. And it took us a little bit of time to come up with multitask jobs. And these are the workflows where you can have more than one task in it. So now you can start chaining these together. You can create DAGs of work to be done. Pretty awesome. And that unlocked, let's say, that was the first time we unlocked complex workflows on Databricks, because previously you had to use Airflow or Azure Data Factory or some external orchestrator, because most interesting workflows are multi-step. In 2022, we just spent a lot of time scaling the service. So no surprise, one of the most important guarantees an orchestrator can make is that it itself is up and running. And not just up and running, but it's actually able to handle the load of millions of concurrent workflows running on behalf of our customers, right? And the guarantee that we made was that you, as a customer, will not notice that you can launch hundreds, even thousands of concurrent runs, and we'll take care of it for you. And the thing we had to do here was really make sure that we protect you from the problems of the cloud. That if there's an outage in a region, we can go to another region. We can deal with cloud APIs returning errors and so forth. And then, what have we been up to since then? There's actually a whole lot. And I want to show you what Jobs has become and where it's going. So today, I think of Jobs as a complete orchestrator for the data intelligence platform. And let me share some things that we've done lately that are super powerful, and you may not actually know about. So first is a category of capabilities, what I call advanced control flow. For example, this means you can now set parameters at the job level and task level. And these parameters are unified. So one thing you may not know this is Jobs has this thing called task types. A task is a thing you can run. It could be a Python script. It could be a DBT project. It could be a notebook. So now you can set, in a uniform way, you can set and cascade parameters across job and its task types and into the code itself. You can do branching in Jobs, which is super powerful. So the reason we built this is because often in a job, you want to stop and you want to review your execution. So you may have a declarative pipeline that runs, and you want to say, hey, I want to go and look at the number of rows that were written. You may have a notebook that runs, and you want to inspect the output of that notebook. So this sort of branching and decision making is extremely powerful, and that's available in Jobs as well. And if you're not using it, it's very simple. And of course, you can pipe in task values, the output of different parts of the workflow, to make decisions. Then you have looping. Again, super, super powerful. Looping is exactly what it sounds like. If you want to do the same thing, do lots of notebooks, and you want to run it again and again, that's exactly what looping is for. And with looping and branching and all these capabilities, you get retry semantics, which is super powerful. What I mean by that is, imagine if you ran a workflow and everything worked except for the last thing. You really don't want to run all the others. So with retry semantics, you can choose what to run again. You have task values, which is how you pass data from task to task. So for example, you can pass along a few kilobytes of state along the workflow. And finally, this is super cool. We just announced this recently. It's called SQL references, which means that when you run a SQL script, you can actually inspect the result of that SQL script, get the result, and pipe it to the next task. So if you're building SQL-centric workflows, super powerful. So when I look at jobs, this is a far cry and greatly expanded capabilities from 2016 when this was its primary job was to bring up a Spark cluster and submit work to it. It lets you model most, I would say, pretty much all potential workflows that you see in the real world. The one thing we don't have today is a sort of a human sort of pause the workflow and contact a human kind of operator or a task. After I'm done with the talk, we'll have some time. I'd love to hear from what's missing here. I think there are a couple of things that are missing. The other thing that we spent a lot of time doing was what we call orchestrate everything. And by the way, this is a little peek into the new UI for jobs. And what's cool about this is that these are the task types that are now available. There are notebooks, Python scripts, dbt projects. Tomorrow, we're announcing that we can orchestrate Power BI. We're orchestrating dbt Cloud as well. And in fact, the reason why I like this is there's so many, we're running out of space. So that's pretty awesome. One of the very common things that I hear from customers is, this is fine, but I want to orchestrate a REST API. Can you do that? And actually, we can. And if you're using serverless compute, a serverless notebook is a great way to do that. So typically, the code to reach out to a REST API, get the data back, parse it, and do error handling is pretty small. You could use the assistant to generate it. The bigger problem has been, I don't want to spin up a large Spark cluster with a driver and wait for it to come up if I'm making a quick API call. And that's exactly why you should use serverless compute. So you can use a notebook with serverless compute, spin it up, it spins up within seconds, do your API call, shut it down. So with that, pretty much everything is within the realm of possible when it comes to orchestration. And we're going to keep adding. Actually, I don't know if you noticed this, but at the very top, you also see these icons for Lakeflow Connect. Lakeflow Connect is also now integrated into jobs. So from within your job, you can add data and orchestrate it. So pretty cool. I want to talk a little bit about, I just called it scale, scale, scale. First of all, serverless compute is really big. So we spent a lot of time, about 1.5 years, to build the capability to integrate serverless compute into Databricks jobs, into Lakeflow Jobs. Of course, classic compute is fully supported. You can keep using it. But now you have serverless compute. There are 2 modes of serverless compute. One mode is performance optimized, which means it comes up really quickly, comes up in order of seconds, and it scales up really quickly as well. And this is suitable for certain workloads, let's say more interactive-like workloads. We have a strict SLO you want to meet. But there's another mode of serverless, which is called standard mode. You basically turn off the performance optimized mode. And then the spin-up time for standard mode serverless compute is about 6 minutes. It's anywhere between 4 and 6 minutes, which is sort of like a classic compute cluster, but it's much cheaper. And so this way you can choose. You can choose between freshness and latency. And the great thing about serverless compute in jobs is that it's a way to kind of offload infrastructure. So if you find yourself today thinking about clusters, cluster policies, what's the right size, is it at the right DBR version, serverless compute in jobs automatically upgrades. So we take care of the versions for you. We take care of the infrastructure. We take care of the scaling. So if you haven't tried it, it's pretty awesome. And this is actually a way to scale your organization. That's why I included in the scale, scale, scale bucket, where you may not have enough people, enough experts who are great at managing clusters, again, to get you back to doing data engineering. And there are several sessions on serverless compute, so I won't dwell on it too much. The second thing, which I'm super excited about, is task queuing. So what would happen in the past with jobs is that there was a limit. It's a service. Every service in the world has a limit. And if you tried to run too many tasks, it would say, I'm sorry, 429, back off, and it wouldn't run your job, which is very disappointing. So we spent a lot of time building task queuing. And you can enable task queuing. I believe it's turned on by default now. But you may want to take a look. It's in the right sidebar. And with task queuing, what happens is that we hold on to the task for you. So if you've reached that limit, and the limit is actually quite high, I think it's like more than 1,000 concurrent runs, we can just hold on to that, and we'll run it when the queue empties up. we've spent a lot of time just raising the limits on the number of tasks in a job. For example, I think you can have more than 1,000 tasks in a job now. It used to be 100. So you can truly build large workflows, and we'll render them for you so you can actually manage them, and then we can run them for you. DevOps is big, and this is one where a lot of people don't know how much we've done to make LakeFlow Jobs friendly for people who are coming from the world of Airflow, Daxter, Prefet, but really people who want to write their jobs as code and then manage the lifecycle through CI/CD. This was actually really hard several years ago. So let me talk about two things. So first of all, now you can write your jobs using Python code. Pretty awesome. So you can express this in Python code, and if you're coming from the world of Airflow, it's quite similar. It's super powerful. Then who here is using Databricks asset bundles? Okay, a lot of hands went up. So if you don't know what Databricks asset bundles is, it's a way to express the objects that are deployed, jobs, pipelines, notebooks that are deployed into the Databricks workspace. So it's config-driven. So you can now integrate your job as code with Databricks asset bundles and have testing and CI/CD all along the way. This is a great way to, as you start maturing, as you start building larger and larger jobs, it's a great way to make sure they go through stage gates and have quality. So the full DevOps lifecycle is completely possible with jobs now. So one thing I wanted to do, and we'll do a super quick thing here, is I spent a lot of time on jobs, spent a lot of time on Connect, and Michael gave you a little preview of how we're renaming DLT into declarative pipelines. Actually, I promised a demo in this session. I'm going to give you a demo. And what I'm going to show you is this is our dog food environment, so fingers crossed. I'm going to show you how easy it is to create a declarative pipeline. So who here has created a DLT before? OK. So if you created a, thank you. And if you created a DLT, you're probably familiar with the old notebook-based experience. And notebooks are good. They're good for exploring data. But for a declarative pipeline, where actually the whole thing gets analyzed and run as a whole, the imperative model of notebook didn't work really well. So I'm super excited. You're going to see this tomorrow. There's going to be a big demo for this. But you guys are all here, so I'm going to show it to you first. We have a brand new IDE for data engineering. It's purpose-built just for building declarative pipelines. So I'll just do a live demo and hope it all goes well. So you go and click New, and you click Create Declarative Pipeline. And I'm going to call this Taxi Analytics. So the whole thing behind this editor, I'm going to hide this real quick. The whole thing behind this IDE is that we wanted to give you a collaborative UI-first way to get started, to make it super easy to get started with data engineering, make it not daunting, but also to give you all the data engineering is sort of unlike other disciplines. You care about things like tests. You care about things like data sampling. You care about things like quality. So you wanted to make sure that this is a purpose-built editor just for data engineers. So let me show you real quick. I'm going to call this Taxi Analytics because I'm going to be working off of a sample taxi data set. And I'm going to choose just this one. And I'm going to just say, hey, just give me some sample code in SQL. And of course, this is declarative pipeline, so you can mix SQL and Python. All right, so over here, you have your file tree in the IDE. You can organize. This is convention-driven, but you can organize your code the way you like. This is not going to be in tomorrow's keynote, but we are adding testing. So very soon, you'll see a native testing framework for declarative pipelines and a test runner, and testing is going to be fully integrated into this IDE. And what I have here is also a pipeline graph that's going to show up here. I'm going to run the pipeline real quick, but let me show you the code. So what I'm doing here is there is a data set in our test environment, which is for taxi pickups and drop-offs in New York City. Okay? And what I'm doing here is I'm creating a pipeline which computes zip codes and the fare amount, and then also computes the total fare. Okay? So what I want to show you here is that this is declarative programming, right? So, oops, sorry about that. It's basically, if you're coming from the world of DBT, it's queries. You tell the system, here's the transformation, and we take care of it for you. And this is our dog food environment. So, oh, there it is. So the serverless compute is coming up. This is available with classic compute as well, but I'm using serverless compute. So I'll show you the graph as soon as it has rendered. to show you the new editor. Give it a sec. Here we are. OK, perfect. So what I'm doing here is I'm going to use the graph to navigate. So OK, I am reading. I'm just doing a select from samples.nyctaxi.trips. And the graph here showed you that it read 22K records, right? Then I have a follow-up transformation, which is this one, which is then reading from the previous table, and it's just doing a group by on fair amount. This is obviously a toy example, but notice that as I click on this, I see data samples at the bottom. And this is one of the big pain points with developing DLTs, which was, you wrote your code, then you had to kind of walk away until sample data appeared. This is super snappy and serverless. You get table metrics and performance built in. So you get query profiles integration. So if anything is ever slow, you want to see what's going on is fully integrated. And of course, I don't have this integrated with Git, but Git is integrated. Databricks asset bundles are integrated as well. And scheduling is integrated here too. And of course, you can manage all your settings from here. And one thing that is kind of cool is I want to show you this, and this is live demo. I'm going to show you the assistant integration. I'll just say add data quality checks. Perfect. And I'm almost done with the demo because I want to leave 5 minutes for questions. Oh, that did not go well. Sorry, this is why it's a live demo. Maybe I do something like here. Add data quality. There it is. OK, perfect. So that worked. So we're still working on the assistant integration. But generally, the assistant is much better at understanding this code and generating suggestions for you. OK, awesome. So this is the new IDE for data engineering. This is how you build Lakeflow declarative pipelines. Let me stop here. We have a little bit under 5 minutes. I want to make sure we have time for questions. Happy to take any and all questions.